So we have seen that if we have a physical system for which the acceleration is constant, we can use kinematic equations to analyze that system. And we looked at a particular example of a system for which the acceleration was constant. And that is the system which is in a state of free fall. And we defined free fall by the acceleration of the system or of an object in the system is equal to g 9.81 meters per second squared downwards. Some people say negative g, which is totally fine, but that depends on your coordinate system. Whether or not it's negative or positive depends on your coordinate system. What we do know is that gravity always acts downwards, and so the acceleration due to gravity is also downwards. And just as a reminder, that's 9.81 or so meters per second squared. You'll find different people using different values, 9.8 or 10 or things like that. I'll stick with this because we all have calculators and it's easy to type in 9.81. Free fall. There's another system for which acceleration is constant that turns out to be pretty darn important, and that is the situation for which the acceleration is equal to 0. You can put in units if you want to. We normally don't, but that's okay. This system is called, we say that this system is in equilibrium. Now we are definitely going to expand on the concept of equilibrium when we start talking about forces. We're going to come back and revisit both of these systems when we start talking about forces. But this turns out to be a pretty important situation. It's also mathematically usually a reasonably easy situation to handle if your acceleration is 0, at least if you're talking about kinematic equations. Any term with an acceleration just goes away. The acceleration is equal to 0, therefore any multiplicative term is equal to 0, and we have the state of equilibrium. Now, what we're going to see in the next video is that if we start to analyze systems in 2 dimensions, we're going to figure out that sometimes both of these situations are applicable to a system at the same time.